Every second, thousands of people around the world are sending crypto, Bitcoin, Ethereum, whatever, from one wallet to another. No bank, no middleman, no phone call to authorize it. But here's the question nobody asks. What actually happens between the moment you hit send and the moment it arrives? It's not magic. It's not just the blockchain does it. There's a whole mechanical process happening underneath, and once you understand it, you'll never look at crypto the same way again. Welcome back to Chain Decoded, and today we are going deep on blockchain transactions, what they are, how they're built, how they get verified, and why sometimes they take forever. Let's get into it. Okay, let's start with the basics. A blockchain transaction is, at its core, just a message, a digitally signed instruction that says, I, this specific wallet address, want to send this specific amount to this other specific address. That's it. That's the seed of every transaction. But the beauty and the complexity is in how the network handles that message. Think of it like mailing a letter in the real world. You write the letter, you seal it, you put a stamp on it, and you drop it in the mailbox. The postal system, completely independent from you, picks it up, moves it, sorts it, and delivers it. The blockchain is that postal system, except instead of postal workers, you have thousands of computers, called nodes, spread across the world, all working together to make sure your message gets through correctly. And unlike the postal system, nobody can open your letter, nobody can fake your signature, and nobody can lose it. Once it goes through, it's permanent, immutable, forever recorded. Now, let's crack open a transaction and look at what's actually inside, because it's not just from address A to address B. There's more going on. Every transaction has a few key components. First, the sender's address. This is your public wallet address. Think of it like your account number. It's visible to everyone on the network. Second, the recipient's address, where the funds are going. Third, the amount, how much crypto you're sending. Fourth, and this is the one people overlook, the digital signature. This is generated using your private key, the secret code that only you hold. The signature proves, mathematically, cryptographically, that you authorized this transaction, not someone else, you. And fifth, the transaction fee. We'll talk about fees in detail later, but in short, it's a small amount you pay to the network as an incentive for miners or validators to process your transaction. Now, on Bitcoin specifically, transactions also have inputs and outputs. This is where it gets a little different from your bank account. Instead of having a running balance, Bitcoin tracks unspent transaction outputs, UTXOs for short. When you receive Bitcoin, you receive a UTXO. When you send it, you're actually spending that UTXO and creating new ones. It's kind of like paying with physical cash. You hand over a 100 rupee note, you get change back. Bitcoin does the same, just digitally and tracked on the chain. So you've created your transaction and broadcast it to the network. Now what? First, it lands in what's called the mempool, short for memory pool. Think of this as a waiting room, a giant public waiting room where all unconfirmed transactions sit until a miner or validator picks them up. Every node on the network that receives your transaction does a quick check first. Is the digital signature valid? Does the sender actually have enough funds? Is this a duplicate transaction that was already processed? If it passes those checks, it's admitted into the mempool. If it doesn't, it's rejected on the spot. No exceptions. Now, miners in a proof-of-work system like Bitcoin are constantly competing to bundle transactions from the mempool into a block from a pool. They prioritize. All right, transaction fees. This is the part that confuses and frustrates a lot of people. Why does sending crypto sometimes cost a few cents and other times cost $20? Here's how it works. Miners and validators have limited space in each block. Think of it like seats on a flight. When demand is low, everyone gets a seat easily. When demand is high, During a bull market, a big NFT drop, some major on-chain event, there are more transactions than available space. So miners and validators do what any rational economic actor would do. They pick the transactions with the highest fees first. On Bitcoin, fees are measured in satoshis per byte, sat/v byte. The bigger your transaction in data terms, and the higher the fee rate you're willing to pay, the faster it gets confirmed. On Ethereum, it got more sophisticated after the EIP 1559 upgrade. There's now a base fee, set by the network algorithmically, plus a priority fee, also called a tip, that you add to incentivize validators to pick your transaction faster. The base fee gets burned, actually removed from circulation. The tip goes to the validator. It's a genuinely clever system. Pro tip for anyone watching: if you're not in a rush, check network congestion before sending. Tools like mempool.space for Bitcoin or etherscan.io's gas tracker for Ethereum let you see live fee recommendations. Sending on a Sunday night is usually much cheaper than during peak trading hours. In the next episode, we will discuss about smart contracts and how it works. If you like this video, hit the subscribe button and share.